So still, section 2.2, linear programming. This was a second example of a word problem that we worked in class. War Eagle Bakery makes decorated sheet cakes. This point, my eyes start to glaze over and blah, blah, blah. And I just like, okay, let me scroll. Where's my question? How many batches of each type should they make? That's going to help me define my variable. So batches of what? What are they? Well, it's batches of sheet cakes. There's a full and there's a half, okay? So how many batches of each should we make? Those are my variables. So I'm going to say that in this case, we'll let F equal, so the batches of full, and H equal the batches of half, okay? And then from there, the objective function, what am I trying to do? I'm trying to maximize, it looks like profit. So I want to maximize my profit. So there should be a function profit. How does that relate to my variables? So I make a profit of $30 on the full. So $30 on the full, and I make 35 on the half. So 35 on the half. That's my profit function. So I've got my variables defined, my profit functions. Now I just need to figure out what the constraints are. So you will notice I wrote F down first. So I will go down here and make sure I know that's F and this is H. Those are my two axes. And I'm also going to write F here. I'm going to be very consistent. Every time I write those variables, F comes first, H comes second. Now, if I read through the problem, my constraints, what are the broad categories of constraints? It feels like I'm constrained around my oven time and my decorating time. And then they give me specifics about it. So those are my constraining points. So I'm constrained with my oven time and my decorating time. So, and then decorating. So let's look at the oven time. A full sheet takes 4 hours of oven time. So 4 hours for a full in the oven, and 2 hours of decorating. So the full takes 2 hours of decorating. And then the half takes 2 hours of oven. So 2 hours there for the half takes 2 hours. And then it also takes 4 hours of decorating. Okay. And then if I look at my other constraints, both of these ovens are available for at most 24 hours a day. So I can use them for up to 24 hours a day. And then the other constraint is the number of sheets that I bake obviously has to be positive. I can't bake a negative number of sheet cakes. So that's how I'm going to get all my constraints. I can move down into writing those constraints and then graphing. So my constraints are that F is greater than or equal to 0, H is greater than or equal to 0. Those are the trivial constraints. And then I've got 4F, and this is where I always use my colors. So 4F plus 2H is less than or equal to 24. And then 2F plus 4H is less than or equal to, let me make that a little bit clearer. 2F plus 4H less than or equal to 24. So those are the constraints that I need to graph. So let's look at each of those lines. First case here. So F and H. When F is 0, H is 12. When H is 0, F is 6. Second line, F and H. When F is 0, H is 6. When H is 0, F is 12. So I need to scale up to 12. F needs to go from 0 to 12, and H needs to go from 0 to 12. So we're probably just going to do that like this. We'll just say 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Okay, let's graph the green one. So 0, 12 is here, 6, 0 is here. So I'm going to draw a line between both of those. Okay, and if I go to the red line, I've got 0, 6, which is right here, and 12, 0, which is right here. I will draw a line between those two. So, okay, now according to my inequality, if you look at that, I'm shading below the green line, below the red line. So to shade below the green and below the red means I'm shading this area right here. Okay, so that is my feasible region. Okay, once I have the feasible region, I look at the vertices. There's a vertice right there. Here's one, and here's one. So I have 4. Some of these are pretty easy to define. So I know that I've got 0, 0. Where the red line meets the h-axis is 0, 6. Maybe if I write that in red, that would help. So I know that I've got 0, 0, 6. And where the green line meets down here, I know I've got, 6, 0. So I've got these 3. And then I just need to find where the red line and the green line intersect. So red line and green line. So remember, I've got the green line is 4f plus 2h equal 24. The red line is 2f plus 4h equal 24. I can solve this for f and h. So I can solve it using matrices. So that's going to be 4, 2, 2, 4 inverse times 24, 24. So I can do that on my calculator pretty quickly and avoid arithmetic mistakes. So I will say menu, and I'm going to create a 2 by 2 matrix. So that matrix is 4, 2, 2, 4, 4, 2, 2, 4. And I need to take the inverse of that matrix and multiply it by another matrix, which is a 2 by 1, so 2 rows and 1 column. That matrix is 24, 24. So I do that and I get 4, 4 is my answer. So that means that if I look at 4, 4, that means that f, h equals 4, 4. So f is 4, h is 4. This point is 4, 4 right there. That's my other vertex. So 4, 4. You get here, this is all the heavy lifting. Now it's just substituting back into that profit function. Profit function was what? 30f plus 35h. So I'm going to have, so the profit at 0, 0 is going to be 30 times 0 plus 35 times 0. That one's 0, we got that one. So the profit at 0, 6 is going to be 30 times 0 plus 35 times 6, and that is 210. And let's move on to the next one. The profit at 6, 0 is going to be 30 times 6 plus 35 times 0. That's 180. And the profit at 4, 4 is going to be 30 times 4 plus 35 times 4. So that's 140 plus 120, which is 260. So if I'm maximizing profits, that's the maximum right there. So my answer would be that, the max profit is $260, and that's when I make 4 full and 4 half sheet cakes. So maximum profit's 260 when I make 4 full and 4 half sheet cakes. Again, long problem, but repeatable process. It starts with reading the problem, going to the question. The question gives you the variables. Okay, go back to the problem using your variables. That gives you the objective function. Once you've got the objective function, read all of the other numbers in your problem. That's where you're going to sniff out the constraints. Once you have the constraints, write those down, map it to get your feasible region. Then the next challenge analytically is all your vertices. Usually a couple of the vertices, or several of them, you can already figure out because you've already plotted them. Usually the one that you have to work on is where two lines intersect. And where two lines intersect, I can use algebraic methods to do this, or I can use my calculator. Now, if you need help with that, if you go back to where we started in the unit 2.1, if you look at the very end of that, here are instructions on page 60. You can algebraically find when two lines intersect. So here's an example of two lines right here. Algebraically is the first column. You can use matrices like we did on the second column, or you can use your solved system of equations. So however you want to do it. First method, algebraically, prone to mistakes. The second two methods require the calculator, but you've got to be pretty adept at using the calculator to make sure you can get that information. So many tools to get that. I feel like leaning on the calculator is a good thing because when you get the test, you don't want to get bogged down in making arithmetic mistake, and you want to make sure you use the most of your time. So I would advise you to take advantage of that method. So anyway, that's the second problem that we worked on section 2.2 in linear programming.